Hello friends, so today I will teach you about standard signal generator. Standard signal generator. So a standard signal generator is a radio frequency signal generator which produces known and controllable voltage. Okay, so basically it is a radio frequency signal generator. It generates signal which are in the range of radio frequencies, and its main job is to produce known and controllable voltage. Don't worry about the notes, I will provide you the notes at the end of this video. So yeah, a standard signal generator is a radio frequency signal generator which produces known and controllable voltages. And this signal generator is basically used as a power source for the measurement of gain, signal to noise ratio, bandwidth and other property. Okay, so second point you can say that it is used as a power source. And when it is used as a power source, you can measure signal to noise ratio, gain and various other properties. And it is extensively used in the testing of radio receivers and transmitter. Okay, you know that it works in the radio frequency range only. It generates a signal. It generates radio frequency signal, and hence it is used in the testing of radio receiver and transmitter. So basically you have to remember three very important points about standard signal generator. First, it is a radio frequency signal generator and it produces known and controllable voltages. Second, it is used as a power source for the measurement of gain, signal to noise ratio, bandwidth and other properties. And third, it is extensively used in the testing of radio receiver and transmitter. So basically you use it for testing of radio receivers and transmitter. What is radio receiver? And radio receiver which receives the radio signal, and radio transmitter is the one which transmits the radio signal. So it is used in the testing of those components which receives the radio signal and transmits the radio signal. Now I will make the block diagram of standard signal generator. So first you have an RF oscillator. Range is selected, frequency is also selected. Then after that you have wideband amplifier. After that you have output attenuator. Then you have output level. In wideband amplifier you have modulation oscillator. And also an external oscillator. Fine. So basically this instrument, standard signal generator, is provided with the means of modulating the carrier frequency. You know what carrier frequency is, right? Carrier frequency is the one which carries your information. by modulating your carrier frequency, basically by modulating your carrier signal according to your message signal, you obtain an amplitude modulated or frequency modulated, like whatever you will, if you modulate the frequency of carrier according to the message frequency, then you obtain an frequency modulated signal, and if you modulate the amplitude of carrier according to your message signal, then you obtain amplitude modulated signal. And this modulation is indicated by a meter, and your output signal can be amplitude modulated or frequency modulated signal. And modulation may be done by a sine wave or a square wave or triangular wave or a pulse. Fine. Meaning you can have any wave for modulation. So our carrier frequency is generated by this RF oscillator. Okay. So our carrier frequency is generated by a very stable RF oscillator, and it uses an LC tank circuit, and it has a constant output over any frequency range. So basically our carrier frequency is generated by a very stable RF oscillator using an LC tank circuit having a constant output over any frequency range. So our amplitude modulation is done by an internal or an external oscillator, fixed frequency oscillator. So modulation is done in output amplifier circuit, or you can say wideband amplifier. Modulation is done in wideband amplifier using external or internal fixed frequency circuit. And this wideband amplifier delivers its output, that is your modulated carrier, to an attenuator. Attenuator is what? It varies the amplitude of the signal. It basically decreases the strength of the signal so that you can see the entire output on the screen. Basically so that you can observe the entire signal. Okay, and then the output voltage is observed in an output meter. So basically carrier frequency is generated by a very stable RF oscillator. Modulation is obtained by an internal or external fixed frequency oscillator, and then modulation is done in wideband amplifier, which delivers its output to an attenuator, and the output voltage, that is your output signal, which is voltage only, right? The output signal is observed in an output meter. So what are the disadvantages? Your first disadvantage is frequency stability. Basically frequency stability is limited by the LC tank circuit. Where are we using LC tank circuit? In RF oscillator. So it is limited by the LC tank circuit design of the RF oscillator. Basically to range switching, since range switching is usually accomplished by selecting appropriate capacitors, any change in frequency range upsets the circuit design to some extent, and the instrument must be given time to stabilize at the new resonant frequency. So you change the frequency, right, in your generators, signal generators. So changing the frequency, changing the range of frequency is usually accomplished by selecting appropriate capacitors. So this frequency change in frequency range, it upsets the circuit design to some extent, and instrument must be given time to stabilize at the new frequency that you have set, at the new resonant frequency. So you see, frequency stability is limited. You can solve this problem by regulated power supply. Regulated power supply are used for frequency stability at all ranges, and to maintain a temperature, compensation is used. And the second problem that we have is isolation. In high frequency oscillator, it is essential to isolate the oscillator circuit from the output circuit. The isolation is necessary because change occurring in the output circuit will affect the oscillator frequency, amplitude and distortion characteristics. Okay, so you need to isolate your output circuit from your oscillator circuit. You can solve this problem also. Buffer amplifiers are used for this purpose. Advantages: the output voltage of the conventional standard signal generator can be controlled as per the requirement. You can control your output voltage as per your requirements if the output obtained is stable. Can control. Second, stability.